Hello, everyone. Welcome to our webinar today, The Transformational Power of Concrete Stain. I'm John Ricco, APA Executive Director, and we're glad that you could join us here today for this event. And before we get right into it, we are going to take a few minutes here to just talk about some housekeeping items. And so first, we'll talk about some upcoming events. And first and foremost, what we've got is our spring workshop in 2024, which will be April 3 through 6 in Tacoma, Washington. That is going to be a great event, a lot of hands-on stuff at Northwest Precast Plant up in Tacoma, Washington. So we encourage you to be on the lookout for information on the website and to join us out there for that awesome event. Also, our next upcoming webinar will be January 17th with where Lisa Barnhart with GCP Applied Technologies /CRISO /St. Cobain, multiple name changes here recently. We'll be talking about environmental product declarations and the Living Building Challenge and help giving you some tools and suggestions for how you as precasters can navigate those items. We'd like to make sure everyone's aware and participates in a discounted saving program we have with ODP, which is Office Depot's business-to-business online portal, substantial and significant savings that you can achieve through participating in that contract. So we encourage you to check that out on our website and hopefully save yourself some money on some office supplies. And then last but not least, this is one of many ways to earn continuing education if you hold any APA certifications. So please check out the other webinars, which are on our YouTube channel. We also encourage you to like and subscribe, mash that button wherever it is so you get notifications whenever we come live with an event, so you're aware of all those things. But there's also multiple ways in which you can earn continuing education. So with that, I'll kind of ease here into our presentation today. And so with that, I'm going to pull up Dave Ellis with NACA. I'm going to do a brief introduction, and then we'll turn it over to Dave. In terms of the session, once we begin, those of you who are logged into a YouTube account, you can submit questions by just going into the chat feature. Don't worry if you're not logged into a YouTube account. Across the bottom of the screen throughout the webinar, there'll be an email address where you can send questions. So if you have any, you can submit them there as well. So with that, I'll introduce our speaker today, Dave Ellis. He's the North American Sales Manager of NACA Incorporated. His wide-ranging knowledge of silicate technology and stain solutions for concrete and masonry are put to work supporting construction and renovation work worldwide. His unorthodox path to stain through his time in public police service, promotions, and extreme sports give him a unique perspective on problem solving, resilience, and lots of good stories to tell. So with that, welcome, Dave, and I'll go ahead and turn things over to you.
All right, awesome. I really appreciate it. And we'll start off this presentation with thanking APA for just being a fantastic organization and constantly supporting the industry and supporting everybody. And we really appreciate what you do, and real thanks to you guys. So I like to start these things making it personal. So who am I first before we start this presentation? So obviously my name is David Ellis. I started my younger years in extreme sports. I did rollerblading on half pipe. I came 10th in the world in 1998. I also did freestyle skiing, which I competed in constantly. And then I went from that to breaking my knee and bought a house next to a police officer. And so he said to me, okay, do you want a job? So I said, sure. So then I became a police officer for 15 years of my life, which was a great learning experience. And then I transitioned into sales, which I am in now with NACA. So that's kind of who I am. I hope it's a wealth of knowledge to bring to the table, but we'll see how this goes. NACA has been in business for over 34 years. We are the industry leader in potassium silicate stain and staining technology. Where the company started really was the brick manufacturers would send the wrong brick out to a house, and then the bricklayer would put it up, and then we would send a crew to match the color of the original brick and stain it. So the company has transitioned numerous times over the years into where we are now. NACA is a global company. We have crews everywhere. We don't sub our work out. We all in-house do the work. But the real purpose of this webinar is to talk about potassium silicate stain, which I'll get into now. So we're going to talk about how it can transform concrete into anything you want. This is a copyrighted presentation. Please, anytime email me. I will send you the presentation. We can talk about it, but it is copywritten. So what we're going to talk about today is the science of stain, how stain works, how it chemically binds with the concrete, what requirements you need to stain a building, how you can use this potassium silicate stain to equalize out panels, make panels look like certain things, faux finishes, things like that. And then I'm going to show so many examples of how that is actually in real life experiences. I also talk very fast, so I'm going to try and slow myself down. And if you guys have any questions, please, John, interrupt me during the whole process. So what happens when you guys paint surfaces? So we always call it's paintnance. You're going to have maintenance when you paint something, okay? So right away, when you paint something, you're mechanically binding the paint to the surface. And the way I like to explain it is like a car wrap. So when you put that vinyl wrap on the car, you're putting the vinyl wrap over, it's mechanically binding with the surface. It's not adhering to the surface, it's not becoming a part of the surface. It's just literally sitting over top of the surface. And then this is what happens when you paint surfaces. It's going to trap everything but below it. It's not going to become a part of the substrate. So why stain is so important is it's going to chemically bind, like I said. It's going to act like a hardener, which it's not a hardener, but it's going to act like that. So it's going to go into the surface. It's going to stop UV damage. It's going to stop moisture pushing it away from the surface. It's going to stop it from and let it breathe. So we're going to jump right into some pictures of jobs that we've done. So with precasters and architectural finishes, which is the end goal, is you want to put a high-end finish on a building. Whether you like it or not, like you can make amazing concrete, whether it looks good or not at the end is the real end goal. And there's so many high-end precasters that can use integral color, use different things. But when you actually have the finished substrate, what you want is you want them to be wowed. So with vibrancy and color, that's what you're going to get. So on the top left, it was a barnyard finish that they wanted to accomplish. And so utilizing the mineral stain, they did that. The stone look, it looks painted on the right here, but that's what the customer wanted. These shiplap shingles, yes, yet again, just gray concrete. And they said, okay, can you make it look like shingles? So utilizing the stain, you can multiple layers and put depth and color into the concrete. I love this one. This one was in Texas, and they utilized integral color on the spandrel panels and then highlighting features with dark colors on the standalone portions of the building. Thin brick. So exactly what you look at here, this entire building was stained. So it was just gray precast concrete, and they used a structural mix. They didn't use any fancy mixes, and they just said, okay, can you make it look like the architect wanted? So utilizing your standard mix is fantastic for the precaster, because then they say, okay, this is how I can make this project easy and work with it, and then have them come in at the end to finalize the project. So the science behind the stain, this is what the real bread and butter is here. So potassium silicate stain. So this is a microscopic version of what happens with the stain. So on the left, you can see there's capillaries, there's room for it to breathe. It's going to let water in and out of the substrate. It's going to let anything that's trapped in there out, versus your latex coating on the right. Yet again, that mechanical bond is just going over top of the surface and not letting anything in or out or breathe, or utilizing the amazing aspects of concrete. What we want, I think, as a consumer customer base in our buildings, in our structures, is we want it to look natural. We don't want it to look fake. We don't want it to look, I'm going to use the word painted. What we want is we want it to look natural. So the mineral coating will let everything in and out of the building. It will still look natural. So permeability is the biggest thing. So the absorption rate and diffusion is what's important. So a latex paint will still let absorption into the surface. But what you're going to see the big difference is the diffusion. So in a normal temperature at 21 degrees Celsius, 490 grams per meter squared is going to come into the substrate. And then the diffusion is going to be 95 grams per meter squared out. The difference with a mineral coating is it's going to let a little bit less, 440 grams per meter squared in, but it's going to let 2,100 grams per square meter out. And it's really important to highlight this point because it's not going to push the coating off of the surface. It's going to let the surface be what it is. It's not going to inhibit it. It's going to act like a natural part of the substrate. When you look at different areas where you get into the colder temperatures, yet again, very important. 490 grams per square meter going in, but it's only going to let 50 grams per square meter out on a high-end latex coating. With the mineral stain, it's going to let 1,100 grams per square meter out. So what's important is the freeze-thaw cycle. Apparently, I have a hard time saying that. So when you think about you're making your panels, you're putting them out in the yard, and then they're going to site and they're being erected. What's happening with those panels? They're letting the moisture out of the panels. They're going from green to cured. This is what's important, is what you're doing to the panels and how you're coating them. Here's a great example of what happens when you don't utilize mineral stain technology. So on the top left, cracking and peeling, all the paint surfaces is pushing it away from the substrate. The bubbling and cracking is when UV damage hits it and the heat hits the substrate, and then the substrate is saying, get off of me. I think we've all seen this on buildings a ton of times where, and yet again, we call it paintnance. So if you paint a substrate, it's going to require maintenance. It's going to require constant applications that you're going to have to keep doing over and over. And we're trying to get away from that. What we want is we want our architectural buildings to look beautiful and last for as long as the building will last. So these mineral stains come in any form, any design finish you can possibly imagine. If an architect comes to you with an idea and says, okay, I would love my substrate to look like metallic. I would love my substrate to look like wood. Anything that they can imagine, you can utilize with these mineral stains. They come in metallics, they come in different opacities. They can be layered on top of each other. So with the chemical bind with the concrete, they will bind with themselves. So it will bind chemically with the atoms in the substrate, and mostly the free lime and concrete. So what are the components of this stain that make it fantastical? So we'll talk about mineral pigments. So mineral pigments, there's two different pigments, is organic and inorganic pigments. So if you have like a high velocity color, like high red, high yellow, anything that's like a high color, they need to be made in organic pigments. Inorganic pigments are anything on the other side of the spectrum with earth tones. So when you use inorganic pigments, they're light fast. They're not going to fade. They're not going to decompose. They're going to just last as long as the building will last. The silicate binder is the most important part. And this silicate binder has been around for decades. It's nothing new. It's no new technology. In Europe, they've stained buildings for the last 100 years. There's a small amount of fillers that make up this product, some additives for UV protection and some corrosion protection, and then water. It's literally an organic product. There's no VOC in this product. It is VOC free. So when you look for it for LEED credit or sustainability or environmental impact, you're getting it with this product. Potassium silicate is the base component. So we call it water glass because of the way it looks. So water glass, potassium silicate is the base of this product. As you can see, we have a molecular structure of the product with silicone, oxygen, and potassium. That's what makes up this product. Once it's mixed with water, potassium carbonate, and quartz sand, it becomes water glass. These presentations kill me because I feel like I'm just talking to myself. Sorry, everybody. Silicification is the actual process once you have the water glass and how it's chemically binding with the concrete. So what happens is you put it on the concrete, and like I said, it acts like kind of like a hardener. It's going to, the actual organic pigments or inorganic pigments are going to penetrate into the substrate, but the actual silicification of the chemical bond is going to go deeper into the concrete and become a part of the concrete. Not saying it's a foolproof method. If somebody drives a forklift into the side of the building and chips away the concrete, or if you're in a climate where they're throwing salt and de-icer on the ground, it's going to chemically break down that part of the concrete. But silicification is the actual binding of the mineral silicate stain to the concrete. Opacities. I dislike so much just putting a full opaque stain on anything. I think that the fantastical part of these mineral stains are that you can have vibrant, luminous colors with very translucent stain. So when you think about it, you still want the concrete to look like concrete. If you use a form liner and you want it to look like wood or you want it to look like stone, you can use these different opacities and layer with different colors and textures to make it look like anything you could possibly want. Yet again, we're highlighting obviously here some metallic colors, some gold, bronzes, and red colors, but it can still look like a natural substrate. We're going to go into a couple projects we did. This was in Denver, Colorado. What they wanted was they wanted a mechanical engineering room off the side of the building to look like a mountainous area to blend in with the background. And so what they did was they used actually an Artico Neo form liner, which is a sheet, and then it was highlighted with stain. This was the University of Florida, and basically the only sections of this building that were stained were underneath the window areas, and they wanted a very sublit, muted green color. And so this was 1:10 ratio of potassium silicate stain that was applied, and the rest of the building was integral color in the concrete. Integral color in concrete is a very difficult thing. It can turn out really, really good, or it can turn out really, really bad. So understanding the science behind it and realizing how much you can use of the pigments and not use of the pigments, the answer is use a potassium silicate stain and not worry about it at the end of the day. Have it as the finishing trade. Coca-Cola building. I think this was in Chicago. So this was all structural gray concrete that had a light sand or heavy sandblast on the finish, and they just wanted different variations of the color. This was all one color that was diluted. So all that gray color was diluted to create the finish on that building. Staining requirements. So here what we're talking about is, was there an acid etch on the building? Was there, once it was sandblasted and cleaned and prepped and on the truck ready to go to the building, was it dirty? How did it turn out when it got out? Was there patching? What happened on the building? So stain preparation is a very important part of this. The concrete needs to be at the right pH level, which is between 7 and 10, and it needs to be at the right moisture content. It can't be green concrete. Potassium silicate will, after 3 days, I think it is, I know it is, I'm sorry, can go on green concrete. As long as the moisture level, the pH level, everything is ready for it to be absorbed into the substrate. Color equalization. This is the bread and butter, as I said, of this potassium silicate stain. You can equalize out panels. So if you have a couple panels that are not the same as the rest of the panels, you can just blend those panels and not do the rest. This example, though, was from in Ohio. It was the Veterans Memorial Museum. And what happened was the architect said, okay, I have a vision. I want raw, gray, raw concrete. And then when the building was built, they came and said, this is not good. This is not what we want. So utilizing the potassium stain and diluting it 1 to 5, just blended out all of the concrete. And as you can see here with the finished product, it was fantastic. Things that happen. We have fly ash in concrete. We have numerous things that will occur as it's curing. And it's going to want to push everything out of the concrete. Efflorescence, it's going to want to push out everything it can in different temperatures. This is a version of the fully opaque mineral stain that can hide all of that. It's not going to hide cracks. It's not going to hide structural issues, but it will definitely hide any imperfections in the concrete if you want a one coat system that covers all of it and gives you one finish. We obviously don't like that because we would like to create natural substrates, but it is available. The mineral stain comes in a fully opaque version. Another example used a wood form liner, and they decided that they didn't like the finish at the end of it, and they wanted a one color, one coat system over everything. So you can utilize that with this mineral stain. Indoor, outdoor features, as I said, it's no VOC. It can be used indoor, outdoor, on the inside of panels and the outside of panels, just to blend everything out. Patching, this is obviously a horrendous version of what patching has to happen. It has to happen though. When we transport these panels, when we get them to site, when we erect them, there's going to be issues that happen during the process. So what needs to happen is we need to neutralize the color on the patch and then go over the rest of the substrate or the panel with a semi-transparent stain. Well, I'm going to jump back actually. A very important part of this is utilizing the right patching materials. So it has to be an organic cementous mix to patch. Anything that has polymers or anything plastic or anything chemical in the patch material is not good. The stain needs to absorb, the stain needs to penetrate the surface. You can't use any sort of material that will inhibit that. A lot of these patching materials also have water repellents in them. Obviously it won't work. The stain has to penetrate into the substrate. Stain in action is my favorite part of this presentation. So we're going to show you some examples now of stain in action. Metallics. We've been seeing a lot of interest in metallic colors. These customers want accent panels on their building. They want to see like high-end finishes. And you can utilize these potassium silicate stains to create these finishes. They come in gold, bronze, silver. You can get these metallic finishes and they will look exactly like what you're envisioning them to be. These faux finishes are very capable of happening. This was a fantastic job in Australia. What they wanted to make a new building look like an old building with a copper patine look. And so this was yet again just structural gray concrete, came in, multi-layer system where we put the green on first, we put the bronze accents, and then we highlighted it with a little bit of darkness just to utilize exactly what the stain can do. Another mechanical engineering room off the edge of a building, and they didn't want it to look old or dirty. They wanted to have something that was like fantastical, and they used a geographical map to create this. This form liner was used by US Form Liner, where they decided to create this finish and get the depth, and then the color brought it to life. Accent walls, like I said already, this was integral color on the rest of the building, which I think they did a fantastic job with their white, and then utilizing a 4-coat system here to get the leaf effect on the building. They wanted to look like nature because it was downtown metropolis area. John.
Hey, Dave. Yeah, we had one question come in through YouTube. I don't know if you can see them on the side, but the question is that if the project owner wants a sealer, can a sealer be applied after the concrete is stained?
I hate saying this, but that was a fantastic question. So yeah, absolutely it can be, but it has to be a water-based sealer that's on top of it. Solvent-based sealers do not work well with potassium silicate. It's just trapping everything behind it, and it's not letting the substrate do what it needs to do. It depends on the type of sealer, though. It's like an open-ended question. Like, what are they looking to do? Are they looking to have a water repellent? Or are they looking to waterproof? And those two things are very different. So, waterproof? No, not going to happen. The stain needs to do what it needs to do. It needs to breathe. It needs to let moisture in and out. Water repellent, yes. And water repellent can be mixed in with the stain. So there's 2 different systems that can be utilized. You can put the water repellent on first and then the stain and have that system working together, or you can actually put it into the product and have it as a 1-coat system. I hope I answered your question. Different finishes. We get asked all the time to replicate different materials, limestone, get to marble, so many different things that are asked to replicate with this mineral stain, and it absolutely can be done. This was the only part of this building that was stained was the green part of it on the right, which they used a beautiful bamboo finish on the form liner, and just turned out amazing. Metal paneling. Constantly get asked this question. How much does metal paneling cost? How much does staining cost? How can we utilize architectural precast to make it look like a certain substrate? We are architectural precasters. We are not putting anything on top of our precast. Our precast is amazing and we need to utilize it. So this was smooth panels that were stained with a base coat and then a gloss option on top to make them look like metal panels. These are just smooth precast panels. Color by numbers. I think architects a lot of the time love this idea where they're like, we're going to make it look like this. This just looks like Tetris to me. But having the depth, the perception of the colors, having it like muted, having different pastels, different colors, you can create any finish you want. This is the north elevation of this building, and they decided to go with a different color scheme on each side of this building. This is my favorite project that I've ever seen. This was an airport hangar that The rest of the airport hangars, they just thought were gray and muted, and they wanted to make it look stand out different. So what had to happen here was there was a base coat, there was a top coat, and then it was sponged on the darker highlights. Yet again, the potassium silicate stain will chemically bind with itself, so it's going to still become a part of the concrete. A point I'm going to highlight here, though, is once you go over top of this substrate multiple times with this mineral stain, after 7 times, 5 to 7 times, it will start to look painted. So you want to get the architect's vision and idea, the designer's idea of what they want, and then try and limit it to 5 to 7 coats. If in 10 years they decide they want this to be a totally different color, absolutely can happen. The potassium silicate will still go over top of it, but it's going to have to be a heavier application, and it's going to mute everything that is in that substrate. This was a library that they just wanted to highlight the entranceway. Formliner is the best thing that's ever happened to architectural precast. Once we can do a lot of things with potassium silicate stain to make it look like different substrates, but Formliner is going to revolutionize the texture, the depth, how we can utilize these stains to make different looks. This was in Australia yet again. They wanted to have different wood looks. These were actually ultra high performance concrete panels that they attached to the outside of this building. And ultra high performance concrete, obviously fantastic product. Sometimes it's so dense that there has to be a primer added before you can add the potassium silicate with color to the substrate. So just knowing how to utilize the product and the density and how you can create these finishes is very important. Multiple different looks. I'm going to tell a quick story. I think I'm doing okay on time. The bottom right here that looks like a high gloss finish. We had a customer who wanted to build a total precast cottage, and the township community wouldn't let him build a precast house, a cottage. So he ended up building it and utilizing the stain, stained it to look like wood. And then when the municipal building inspector came around to look at the building, walked around the building and did not know that it wasn't a wood structure or a wood finish on the outside of the building. This is, you can create these finishes that nobody will know they're not real. Great example, Kitchener, Ontario, Canada. John, shoot.
Yeah, hey, we just had another question come in. Is the stain typically applied at the plant or on the job site? So take that one on for us. Thanks.
Okay, so it can be applied in both. It can be applied in the plant, which is a very difficult question. Are they on A-frames? Are they laid out? Are they cured? Or how much landscape does the crews have to like actually physically be on it? It has to be a vertical substrate for it to be applied. Stain, in my mind, I'm the one speaking, but in my mind, has to be applied on site because when you apply it, we're a finishing trade. We can, if one panel is darker than the other panel, the color can be adjusted on site. What will happen is if you do it in the yard or at the precast plant, you're going to find that when it's erected, panel 26 and panel 56 are going to be butted up against each other. And are they going to be equal? They might not be. So the best recommendation for this product is to do it on site as a finishing trade. We've done tons of jobs where we do it in the plant. It's gone great so far. It's a roll of the dice. I think that the stain should be applied after erection. Just another example of a wood form liner finish. This one's a good story too, because I got yelled at and reamed out real bad on this one. So when you do these finishes, make sure that there's an off-building sample, a separate panel that is off the building, near the building, and have those samples ready for the owner ahead of time. So what happened here is we did it on site and we stained it on the top left, and then they came back and they said that they wanted it darker. So then the second picture on the bottom left was us darkening it. The third picture was the finished product, because the GC on site kept coming up to the crews and saying, I want it darker, I want it darker, I want it darker. And so when the owner came back, said, where's my sample? We're like, we finished the building. We did exactly what you asked, what you said you wanted. He was very, very angry with what occurred. So when you utilize these stains, you have to have an off building sample, a panel that's next to the building to replicate what the finishes they want. And it was a really big learning lesson for me, and I ate crow that day. I mean, the building turned out fantastically. Brick and color. So there's so many different types of brick, so many different types of color. There's so many different fantastic products like Endicott that are amazing products. If they don't want to do that, you can also stain the form liner to look like brick. Here are a couple examples. What is important about these slides is the mortar joints. So standard concrete mix, you're going to have a gray mortar joint. Mortar joints make up 30% of the wall panel. So they have to be consistent. I don't think mortar or brick is a consistent product. They need to look natural. They don't need to look simulated or fake. If an owner or architect has a different idea, that's a different scenario. But utilizing these stains, what you can do is you can create these different brick finishes. And the depth, yet again, the form liner, whether you're going to have a concave mortar joint or you're going to have a 5/8 joint, things like that are going to really affect the finish. The best way to do this would be to color the whole panel and then go back and hit the brick faces, because you're gonna get the whole panel and it's gonna be a consistent, equal look. Is that what the designer wants? Is that what the architect wants? It just depends on your customer, right? And that's why you deal with a high-end company who will work with you and go through the sample process and make sure it's exactly what everybody wants. Stone. Stone products are just more and more expensive as the day goes by. Flecking, looking at different splatter patterns, different inconsistent stone looks. These can all be done with potassium silicate stain. I hate to say this, but the crews that actually apply this product, they're artists. What they do is artwork. This was a house in Port Elgin, Canada, and this was all precast, and they just wanted to have a stone facade on the outside of the house. Blending out imperfections, yet again, as I go back to the color equalization thing, I don't know if anybody can see, but on the picture to the right, there was a seam from the form liner all the way down the middle of the panel. And so utilizing the potassium silicate and the color got rid of that seam that was in between the two panels. This was a military base that they wanted to, I think it was in Arizona. They wanted neutral, matte, earthy tones, and just make it look like natural stone. Okay, so concrete and color. Color is going to accentuate the building and make it look the way that the designer intended it to look. We can do amazing things, and we shouldn't inhibit ourselves. When somebody comes to us and says, hey, I have this idea, I want to make this building vibrant and luminescent or whatever it is, then utilizing these pigments, we can do this. We can get the finish they want. This was a school in Florida. Huge companies are using this technology to rebrand themselves and come up with new looks. This is all potassium silicate technology. This is one of my favorite projects. This was in Australia, and yet again, just structural gray concrete that with a high-end finish on the outside of it. These form liners really set the tone for this building. Smooth form liner and some sort of like wood stone form liner that created the texture and the vibrancy of this building. This one's interesting because we didn't want to utilize organic pigments. We had to use the inorganic pigments because this is a high sun area. So what happened here was there was a white base put on the entire building, and then the orange and yellow and red were a top coat that were semi-transparent. But standing back from the structure, you can see that they look vibrant. If you stand directly in front of them, 5 feet away from them, they are matted finishes. So it was an interesting building. What will also happen though with these potassium silicates is different angles and different shades and light will create different views of the building. And that's something that needs to be said right at the beginning of the project. If you have a panel that, let's say, is lightly sandblasted, and then the next panel next to it is heavy sandblasted, and more the aggregate is showing through, when the stain goes in, it's a natural product. It's going to highlight all the imperfections in the panel. And so that's why you hire high quality crews and artists that can blend out the panels. I would love more questions right now from the audience. I feel like I've been talking to myself for the last 20 minutes. Can you stain previously painted surfaces? No, you can't. You have to chemically remove them with a caustic stripper, or you have to remove them with a sandblast. What's the price per square foot? Great question. It's such a vague question. It depends on the access equipment, depends on the look and the finish, the full finish that the designer, architect, or even the precaster has in mind for that project. So I can say easily $6 to $10 a square foot. Could be $3 a square foot. It just depends on the finish. How long does stain take or last is a great question. Staining is a little more tedious and a little more hands-on than painting a substrate. It might take a little bit less. A crew of 2 people can normally do around 1,500 to 2,000 square feet a day of staining. And it's, yet again, depending on the substrate, depending on the absorption rate, depending on so many factors. Are they working off scaffolding? Are they working off swing stage? It's a hard question to ask.
Yeah, Dave, one other question that came in. What about maintenance? What type of maintenance is required after the concrete is stained, if any?
Okay, so what will happen with the stain, yet again, becomes a part of the concrete. It can have normal cleaning done to it. So you can use light duty detergents. You can clean the substrate. You can use a pressure washer, keep it 12 inches away from the wall. It is a part of the concrete. It's not coming off. So you can clean it like you would a normal building. And I'm not trying to make this seem like it's not. The stain is going to become part of the building. As the building gets older and weathers, it's going to weather naturally. The stain is not going to stay the way it is from the day it's put on to the end of the building. It's going to weather naturally. And same thing with the cleaning. You can clean it as you would a normal building, and it's not going to change anything with the building structure or the finish. Please ask me more questions.
I'm not sure if you covered this previously, but is there any kind of special surface preparation that needs to happen before? I know you mentioned pH and those sorts of things. Is there any special preparation that needs to occur?
Yes. So normally a hot water pressure wash is completely adequate. What it will do is it'll clean any debris, surface contaminants, anything off of the building. The pH level will be neutralized when the hot water hits it, and normally that is all is necessary. As architectural precasters, we make the panel, we normally clean it before it gets sent to the site for erection. So the hot water pressure wash is normally, that's all that's necessary.
All right, the last question I have here, and you kind of touched on it, and kind of lends into our next webinar that we're having on living building challenges and all that good environmental product declarations. Are there any issues with VOC or green building or other implications using a stain in these situations?
Definitely not. The product has no VOC in it. It is a natural product. I wouldn't say drink it, but it is no VOCs in it. It's a natural product. It's potassium silicate. It's a mineral stain that is going to be a part of the building. There's no concerns whatsoever. It's so funny. I always go back to California. We can use this product in California, which means you can use it in the rest of the world.
All right, good one there. I don't see any other questions. Oh wait, here we go. How far from the surface does the spray stain have to be when it's applied?
Okay, so it's a very hard question to answer. So it depends on what the finish is, what it wants to be like. So if you're just applying a one coat, one color system on top of standard concrete, then it needs to be applied. It's such a hard question. Actually, I don't have an answer to that question. It depends on the substrate, depends on the density of the concrete, depends on, I don't have an answer to that. Every substrate is different.
Very good. Another question that came is staining a dark shade like a deep black more cost effective than using excessive pigment?
I'm going to do it again. That's a great question. So I actually am going to highlight one of our customers who is amazing. Lafarge built a Nike building in Canada, and they used integral color and pigment, and it was the most amazing thing I've ever seen. They used so much pigment, and it was not cost effective, but like it looks amazing. They do great work. It's half the price of pouring pigment into your concrete and making sure that it's consistent across the whole building. So yes, it's so much better to do a faux finish on the outside of the building that's going to bind with the building.
So yeah, it sounds like that might be one of those, business case situations where, a precaster would have to look at just the cost effectiveness of doing one versus the other.
Yeah, for sure. I mean, yet again, I'm going to highlight another customer. Tyndall made a courthouse in Spartanburg that was the whitest concrete I've ever seen and the most beautiful concrete I've ever seen. And they did it fantastically. How much work went into it? How much did it cost? I don't know, but you can do it. Or if the customer is looking for a cost-effective method to make it consistent and look fantastic, use potassium silicate stain.
Very good. All right, I don't see any other questions. I'll give folks just a moment here to do that. Let me go switch over to email here and check to see if anything's come in.
John, I always like to end my presentations with a joke. So I was really late for this meeting, and I was rushing and I was driving as fast as I could. And I got pulled over by a police officer, and the cop walked into the car and he goes, "I've been waiting all day for a speeding person like you." And I just looked at him. I said, "I got here as fast as I could."
Oh, okay. Well, then that we definitely should end on that note before you come up with another joke. Well, listen, Dave, I appreciate very much your time today and sharing your expertise on staining here. Oh, wait, is that another question? Oh, here, hold on. One more came in right up before we wrap up. How long does the stain take to dry? If for a school application, would summer be the best time?
That's like a four-part question. So the stain takes about 21 days to cure. Once it sits and absorbs into the substrate, it's going to lighten or darken depending on which stain is used. But yet again, there's multiple different products of this mineral stain. But 21 days is the answer to your question. It will lighten as time goes on. So when the stain penetrates and becomes a part of the substrate, it's going to lighten. And then, sorry, John, what was the second part of that question?
Would summer be a good time? I guess as with school being out, would that be a better time to do an application like that?
I completely failed you guys. I didn't even talk about like application weather temperatures. So it can't be applied obviously in freezing temperatures. So anything below 40 degrees, it can't be applied. I'm Canadian, first of all, so I'm going to say 10 degrees, but that means also 40 degrees. And then in the summer, it just can't bake on the wall. So there's so many different types of techniques that can be used to cool down the wall. We're doing a huge project in Texas that it was just unbelievably hot in the summer, and it had to be applied overnight. We utilized lights and had to, because the substrate during the day was 115 degrees, just couldn't be done. So summer obviously is better, but in saying that, it depends on the location of the job. And yet again, I'm not saying that Knockaw is the best. I mean, I think we are the best, but utilize a good subcontractor who's going to get that finish and things that you want. And they need to know this stuff before they apply it, because it will fail if they don't do it properly.
Very good. Thanks. Let's see. Okay, so that is the last question I have in the chat. Let me just do one last check of email. All right. Well, I guess we can wrap this up for real this time. And once again, thank you very much for participating, for sharing your expertise with the APA plants around the country. And I would encourage those watching to mark your calendar for January 17th when we have our next webinar, where we'll talk about environmental product declarations, living building challenges, and what you guys can do to make sure you're best prepared to meet those requests when they come in. So Dave, thank you so much for everything you do for the APA, and have a great rest of your week.
All right. Thank you, everybody.